Welcome. Today we're talking about GCF, greatest common factor. Our goal today is to factor composite numbers and find common factors between two or more numbers. Let's get started. First vocab word. What is a composite number? Composite number is a positive integer that's not prime, meaning it has factors other than the number 1 and itself. So an example would be 4, because that has the factors of 1, 2, and 4, right? 2 is a factor of 4 that is not 1 or itself. What about 9? It's got 1, 3, and 9. Those are the factors. What about 15? 1, 3, 5, and 15. What about 7? Nope, 7 just has 1 and 7 as factors. That's a prime number, a number that only has itself and the number 1 as a factor. Well, how are we going to factor some of our numbers? Well, we can list them. Oops, wrong thing here. So let's list the factors of 24. Well, I'm going to have 1, 2, right? 2 times 12, 3, 4, well, not 5, but 6, 8, 12, and 24. And you'll notice there's a partnership here. So 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. And 4 times 6 is 24. Let's see another example. What about 33? I will have 1 and 3 and 11 and 33. Not very many factors there. I got 1 times 33 is 33, and I have 3 times 11 is 33, and that's it. Let's do one more example. How about the number 60? I have 1 and 2, because 60 is even. I also have 3. I also have 4. I also have 5. I also have 6. Don't have 7. Do I have 8? No. 9? No, but I have 10. No 11, but 12. No 13, no 14, but I have 15. 16, no, I have 20. And then 30, and then 60. So as you can see, if we're going to list factors, those lists can get really long, really fast, and you should know 60 has the most factors of any number less than or equal to 100. Let's move on. We've talked about prime factorization before. It's a vocab term. What does that mean? Let's define it. Prime factorization, man, say that 10 times fast, is finding which prime numbers multiply together to give you the original number. All right? So instead of making a list, sometimes we'll refer to this as the hockey stick method. So instead of making a list, we do, looks like kind of a tree, and we're just listing the prime numbers that multiply together to give me an original number. Let's see what that looks like in practice. So we have a number 32 here. Let's break it down. First thing I like to do is say, is this number even? Yes. So 2 times something equals 32. It happens to be 2 times 16. 2 is prime, so I cannot break this down anymore. So let's look at 16. That's even, so 2 is also a factor of that. 2 is our smallest prime number. 2 times 8 is 16. 8 is a even number, so 2 is also a factor of that. So 2 times 4 is 8. 4 is also even, so 2 is a factor of 4. And I have 2 times 2. And these are both the smallest prime numbers, and they cannot be broken down anymore into whole numbers. And so now I have my hockey stick here. I have 2 times 2 times 2 times 2 times 2 equals 32, or 2 to the 5th power. We can write that. Okay, let's see another example. That's 63. It's not even, so 2 is not a factor, but I can tell that 3 goes into this number. 3 times something is 63. Well, 21. And then 21. 3 is a factor of 21, smallest prime number. 3 times 7 is 21. 3 is a prime number, and so is 7. I cannot break this down anymore. And so I have my very short hockey stick here. And so the prime factorization of this is 3 times 7, which is 3 squared, times 7. So we'll say this equals 32 over here, and this equals 63. And you can do this for any number. The larger the number, obviously, it takes more time. Knowing your multiplication facts is helpful. So now we're going to look at finding common factors between two or more numbers. So let's look at these two numbers, 25 and 55. I know right off the bat 5 is a factor of both, but is it the biggest factor? We can do let's list them first. So the factors of 25 are 1, 5 times 5, and then 25. The factors of 55 are 1, 5, 11, and 55. First, we need to see which numbers they have in common. They have 1 in common, but that doesn't really count because every number is going to have 1 in common, so let's ignore that. They have 5 in common. Do they have any of the numbers larger than 5? No, they do not. So we say 5 is the greatest common factor. Greatest meaning largest, common meaning it's in both of these numbers, 5, and factor, it's a factor in both. Let's try another example. Now let's look at these two numbers, 54 and 27. Let's do prime factorization here. So let me spread them apart a little bit. Okay. So 54, that's even. 2 times 27, I believe. And then I go 27, I get 3 times 9, and that's 3 times 3. There's my hockey stick here. Then let's do 27. 27, I got 3 times 9, 3 times 3. You can already kind of see where this is headed here. So let's look at how many, do they have the same number of the same prime factors? They do. They have 3 3s, each of them. So what I can do is just say, well, their greatest common factor is going to be 3 cubed, right? 3 times 3 times 3, which equals 27. That's an ugly 27. That means 27 is the GCF between these two numbers, 54 and 27. You'll notice 54 is just 2 times 27. This was our first kind of clue right here. That's the greatest number that is a common factor between these two. All right. So let's recap. GCF is going to be the greatest common factor between two numbers. Greatest is going to be the biggest. Common, it has to be a factor in both of those numbers. We can make a list, which can be helpful, and we can do the hockey stick method, which is your prime factorization, okay? For those of you in my class, your assignment will be the worksheet. It's 7.4, a little I. It's kind of an introductory worksheet to the greatest common factor. We're going to be factoring polynomials. So make sure you get that from me. It's also located in Google Classroom. If you have any questions, you know how to get a hold of me. Good luck.